from teaching you how to model systems down to actually modeling the sample system, right? All right. So let's see. All right. So welcome to today's session. Let me pull up Escalidra once again. In the last class, Amaka, please, are you recording already? Yeah, please record. I think we forgot.
Yes. Yes, I'm still recording.
All right. Thank you. Give me a second. Okay. So in the last class we were able to cover a couple of things, and I also shared with us a sample on how to write or how to use MongoDB with Node.js, right? And I also mentioned some of the differences, when you look at relational databases and non-relational databases, and how they relate, of course, especially when it comes to the respective terminologies used in this space. Okay, so remember I mentioned we can do some sort of mapping this way, right? In relational databases, of course, it's still a database. Tables in relational is referred to as collections here, right? Then we have records referred to as documents here, and the column data referred to as the fields here. Okay, so I just wanted you to understand, how this relates with how relational databases relate with non-relational databases. So you can have that in mind. And I said in today's session, we're going to go through data modeling concepts. We're going to go through data modeling concepts, entity relationship diagrams, and database normalization, right? So yes, let's start off from the first one we have here, which is data modeling concept. First off, most of us might not know what we mean by data modeling, and these are terms I really love to explain because I believe understanding the meaning of the terms mentioned here would go a long way to helping you also understand what we are trying to say, so or what we're trying to use that particular stuff for. So we have data modeling. Yeah, let's just say data modeling. Okay, so data modeling. I would also try to make it easy for you to understand by referencing some other things like backend modeling, UI modeling. So these are things you might have heard before, right? So backend modeling, of course, for software engineers, or backend prototyping, right? Prototyping. Okay. If you hear somebody say they're trying to model a system, or they're trying to, model a particular concept on the backend, they are basically referring to, they are basically saying they're trying to implement maybe like a business process, right? In their software, of course, on the back end, which is on the server end, right? If you hear them say UI modeling, user interface modeling, they are trying to show what a software solution would look like from the front end. But now they are basically showing this in form of design, not actual code. Okay. So if you hear them say front end modeling, they are basically trying to. I mean, some people use the term prototyping as well, right? Instead of modeling. When we say data modeling, we are basically describing the process of trying to create a visual representation of either the whole information in a system, especially from the database end, of course, right? Or we're just trying to communicate, parts of it, parts of that information, and also we're trying to show the connections between, the data points and the structures of that particular system, right? I'll give an example. If we say we're trying to model an e-commerce platform, right? So let's just mention, we're trying to model an e-commerce platform. So it means you are going to, try to understand the entities, right, that make up that e-commerce platform. I hope you understood these explanations I gave here. So I think I should add some definitions, right? I believe that would help us here. So let me just write the definition. For those of you that will go back to this recording, of course, I think this will be helpful. All right, so I'll say data modeling is the process. That is not the process of creating a visual. What's wrong with my keyboard? Representation of either a whole information system or parts of the system in order, let's just say, for the purpose of communicating the connections or relationships between the data points and structure. Okay. All right. So I gave an example. We have an e-commerce platform, and somebody just walk up to you. Oh, I have a big, supermarket. I have a big supermarket. Probably I have, this across multiple industries, multiple businesses, and I want to be able to, build a solution, like build a software, where we can also sell online, right? We can also sell online. So we have Mr. John. Mr. John runs a business, a commerce, business. So let's say he has Mr. John has like chains of stores, right? Big stores. Let's call these stores John and Jones, right? John and Jones stores. Okay. Now, Mr. John being this, primary stakeholder here, I don't know why Mr. John calls the store John and Jones, but let's assume Jones is nowhere to be found, and we just have, Mr. John as the primary stakeholder. Mr. John have been running, John and Jones for over 15 years, with a total of 50 locations across Nigeria. So at this point, Mr. John wants to expand his business by moving, to the internet. And the best option here would be, of course, to set up a commerce shop. So right now, they've been doing this, physical business for a very long time. But now Mr. John is trying to branch into the commerce business as well. So Mr. John decided to start John and Jones eShop, right? So let's call it the John and Jones eShop. Now, looking at the fact that Mr. John already has, like, of course, a wealth of experience, running this website here. A wealth of experience running the physical shop. In order to move to the e-commerce, business, Mr. John now employs Leela, right? So Leela happens to be a database engineer, and so at this point, Mr. John hires Leela and say, let me check this call. Who else do I have on the call? Where are you guys? Lawrence. Okay, Lawrence. So let's say Lawrence, and I'm trying to look for the names of those that joined early. Peggy, Roxy. Yeah. So Lawrence and Peggy Roxy are software engineers on this project. Okay, so now they are trying to move to the commerce, business, at least to also expand, their space. Okay, so what happens here is we'll need some people to build the front end, the back end, but of course one of the most important areas here would be the database, because that is where you get to store all these records that the software should have, right? So what we are going to do here is the software engineers break down this commerce shop to say we're going to have front end, which is going to be a mobile front end and a web front end, right? We are going to also have the back end, probably built with Node.js, right? For this example, say this is built with Vue.js, okay? And it means we're going to have a database, and now we are going to use a SQL database, specifically Postgres, right? Postgres DB. Okay, so in order to set this up, Lila would have to at least set up a data model of what this database should look like. So there are tools that Lila can decide to start using. You see, I have a sample here. This is called Plant UML. This is what we basically use in the enterprise space to design databases, right? We can design lots of database, schemas, right? Or database, diagram. This is called an ERD, entity relationship diagram. But I'm not going to jump into this, just immediately. For now, let's just say we have no idea of SQL, right, which is SQL. We have no idea of relational databases, and Lila decides to get into this space, of course, asking some questions, right? Databases, let's say relational databases. Okay, so one thing you start doing is, of course, asking questions. How is this going to work? So of course, you have users. You're going to have users, right? So they'll probably sign up, and you have the products. So when they sign up, they can purchase some products. Now these are assumptions, right? Ideally, you have the business owner walk you through how they want their business to operate, right? So they can say users or non-users can purchase products. I mean, that can come in, but given the example that we have here, we're going to say users will be able to sign up, and they should sign up before they can purchase products. So we have users, we have products, we have the orders, because users basically place orders on products, right? So let's try to look at the relationship from a very realistic standpoint before we start making this look more databasey. Okay, that's not really a word, but yeah, let's just keep it that way. So we have orders, and you probably want to also track the order items, which is not very necessary, but just in case you want to track that, I think it's also fine. So we have the order items, that is the items that have been ordered. Of course, remember, you can also just keep them in orders, and you don't necessarily need to track it at this point, right? Okay, so the reason why I mentioned other items is because, maybe, just maybe, you already have the product, you have orders, and you want to, apply some level of normalization where you can have like order ID, you can also have like the order date and the status of the order. But you also want to use something like the order item to track the quantity of that order, right? And, you also want to track the price in a different table. Now, as I mentioned earlier, you can track everything in one table, but we're just trying to break this down. So this tracks the order information, but not necessarily the item that is part of that order. Or you can choose to just use the orders to track both the item and the quantity, which is still perfect. Okay. So we have the order item, we have the orders, and we'll take off the order item and just replace this with maybe reviews, because we want to say every order should be able to get a review. Okay, now this is optional. The most important part of this system is user, product, and orders. Of course, one thing we're not keeping track of here will be payments, right? But maybe you want to have an external way to manage your payments with things like Paystack or Flutterwave and stuff like that. So maybe you don't want to track payments. Of course, in a robust system, you would want to track payments so you can understand what is going on in your system. But to avoid any complications at this point, I would leave users, products, and orders just to keep the system simple. Okay, so let's try to look at the relationship here. Users would basically make orders, right, on products. It's as simple as that. The users will place the orders on the products. All right, so that's basically what is going to happen in our system. The users place the orders on the product, and then you begin to ask, when you basically understand the entities, these are the entities at this point, right? The user is an entity, the product is an entity, and we are treating the orders as an entity because the orders, would basically have a relationship with the product and the users, right? This is an action. Try to understand that the ordering process is an action, and primarily, we can say that is the main action that our system should have. Of course, we have authentication and some other things, but let's keep track of this. This is the main action that our system should have. So if we have the user entity, you can basically begin to map in the information that should come into the user entity. Our expectation here is that our user can have an ID, right? Every item in your table, because at this point, the entity, the properties of that entity would basically sit in the table as the columns, right? So the properties of a user at this point might be a user ID. Let's use an underscore, a user ID, a username, right? An email, a password, and password, okay? And then you probably have you want to have the dates this record was created. After every point in time, you want to probably track created at and maybe updated at, right? Updated at. Okay, so the reason why I'm showing this now, you should be asking why. What do we mean by created at and updated at? I just mentioned that it's a good idea and a good practice to keep track of them. Reason being that in every table, when you keep track of the date something was created, I mean, it can be created at, it can be date created, right? It can also be date updated. Okay, so it's my personal preference to use created at and updated at. But if you use date created, date updated, it's fine, right? You can just use created, updated. I mean, you see, people actually get to define the standard in their table naming convention, their table and columns naming convention. Okay, so these are the properties of the entity users. Okay, and then we come down to others. So we can begin to when we take a look at this, one thing you would notice is that the others is simply going to be a way to aggregate the information of that user alongside the product that the user is requesting for. So we can basically have the order ID. Then we have the user ID to show the user that is placing that order. We don't need the username, of course. We don't need the email. The user ID is just perfect enough for us. Then we can also get to put the order date, the date this was ordered. We don't need the created at or the updated at, given the fact that it's an order you are placing, right? You can cancel it. So one major thing we want us to track at this point will be the status. And, the status would carry things like, maybe it was canceled at some point, maybe it was properly processed and, so let's say pending or let's say completed. These are things you can track in terms of having a system that, keep tracks of orders. Of course, the status can also depend on how you want to, run your business, right? But let's just, understand the fact that the status here is going to be used to, track the status of that order. Okay. Now, if you look at this very well, you get to understand that you get to ask yourself one question: how can we actually, show the relationship between the order and the product? So what we can now do is to, track the product information as well. What product was ordered? So you can track that with the product ID, right? And then you can also track, things like the quantity that was ordered from that particular product, and of course the price. If you except you want to just link the price to maybe a different table that you call the price table. Basically, these tables can be broken down as I mentioned earlier, so you can actually have your orders and the items that were ordered sit in different tables. But for now, let's just keep it this way. So we have the order ID, the user ID, and the user ID at this point will be used to track the specific user. I mentioned this yesterday, but I'm going to explain this again shortly. So what I'm doing here is to basically show you some relationships, and I'll mention how we can do proper table definition using a tool called Draw.io. So for now, we have the order information, the user information, and then we have the product information sitting right here. So let's try to understand what the product information would look like. First, we have the product ID. So we have the product ID. Next, you want to have the name of the product. So we can call it product name. So product name is fine. Product name. And by the way, remember at this point we already tracked order dates. So order dates is is good enough for this point for this data. We don't need created at or updated at. I mentioned that the reason why we don't need this is because we don't want to always come in to update other information. Instead, we can choose to cancel or we can basically choose to cancel orders. That would be a better approach. So we have the product ID, the product name. We can also keep track of the product description. Yes, so we have a product description. Every product has a price, and of course, when this product was created, as well as when it was updated. So in our system, we create new products. We can also update the product. For example, if we update the name or the description of the product or even the price of the product, we can choose to keep track of this. One thing that we can also do for sure, in most systems we build, most databases we design, we love to also have like a log, right? Or we call it an audit. Okay, we're not going to pay attention to this, but the question is, if a user is, or if an admin is basically updating the price of a product, you want to know who is doing that, right? So you can choose to always log every action. Audit tables are mostly used for logging actions. A user signs in, we log the action. A user places an order, we log the action. A user cancels an order, we log the action. Because at the end of the day, this information you are keeping on that table will be used to perform a lot of, detailed analysis of what have been going on in your system so far. So we're not going to make this very robust, as it should be, but it's just an example at this point, and I hope this makes sense to you. So this is what we have right now. If you notice one thing in common here, you see the others table has the user ID. And I mentioned the other day, I mentioned something called FK. I said that stands for foreign key. And I said we have PK, which stands for primary key. So this also is a PK, which stands for primary key. Right here, you see we have product ID, which we can also use as a foreign key, right? So we can have like, this item reference the specific ID on this table, right? So which is the PK. So let's take a look at the reference here. This basically references this guy. Okay, I'm sure you can see that. The user ID, I already mapped it to the user ID on the users table, right? And then, yeah, so basically we have the, let's see. Okay, so I think that is it. We don't have any other item, referencing another item. But of course, depending on the complexity of our system here, our database, would have a lot of references happening right here on the model design. So this can also be, replicated with other tools. This is an example of a tool that I have here. By the way, I said this is plant UML, so you write code to create some of those information. If we want to design this, we can simply change some of the information I have here. So this is users table. We can duplicate this. So let's just copy, paste. Let's delete some of the information we have on this table. Okay, comment this out. See, okay. So now we have multiple users table. Let's make some changes. So we have the orders. Okay, and we have the products. All right, so within these tables, we can start changing some of the information here. So let's go ahead and delete some of these records so it can match the records we have here. So we have the username, the user ID, username, email, password. All right, so we can have the user ID. Let's make this obvious as the primary key. I'm just going to call that PK, right? And I love to also include the type, right? So if you take a look at this here, we have not included the type yet because we're just speaking to the data points we're trying to capture alongside the references, which is the relationship. But we're not even giving you the detail about the relationship, at least for now. So what I usually love to do is to use this tool or draw.io, which I'll be showing next after this, to showcase the type of data that we're expecting to get there. So I can use UUID, I can use int, right? Which of course works. So basically we have the type of data right there. So I can say this is incremental. Okay, so I can say serial because the serial type in Postgres, for example, means you have an incremental value. So you have 1, the next record will be 2, the next record will be 3, just like that. Okay. So I can also map some other information. For example, the email. I think we started off with the username. So I can say the username is going to be Ivaka, or Ivacha, as so many people call it. Actually means that we are expecting, a variable character type. Of course, it means we can have like informations like magic, just like this. So we can have records like this sit inside this particular, this particular column that we're going to create. I can have the email. So the email expected to also be a voucher. I can have the password, voucher. I can also have the dates created, which is created at and updated at. Okay, so created at and updated at. All right, so this would be a date time type. As you can see, these two also, gives me some of those options. Yeah, so in Postgres, you can choose to use text, right? You can choose to use voucher. Okay, and one thing you see a lot of people do, especially when they are designing DBs, is to put in like the character length that you are expecting to store in here. So it can be 50 for password. If you say you don't want to have items that are that goes beyond 50 characters, most times you see a lot of people use 255. Basically, this is just trying to define a length so that you don't have people stuff in lots and lots of unrealistic records into your database, right? So it's a good practice to also, specify the size or the length. Okay. So in this example, I don't think I would, keep that. But as I mentioned, it's a good practice to have that. Okay. So we have the username, the email, the password, created that and updated that, and we can also include that of the rest items. So we can have our order ID, and I said that is that is yeah. Let's also use a serial. So this is our primary key as a serial, which means it's incremental. We can have the user ID, the order dates. Okay, so the user ID, which of course at this point user ID, has to be an int because it's a serial type, and we're basically going to reference, a different table. So we can say this is, a foreign key to that specific, table here. All right. So we have the order dates, product ID, quantity and price, order dates, the product ID, the quantity, and the price. Okay. So the order date, the product ID, quantity, price, and the status. All right. So we don't need date created because basically the order date is going to, capture that information already. So that's the day the record was created. All right. So for this set of informations here, we can of course we can see that the product ID is eventually going to be a serial as well. Now you must not use serial. You can use an int if you want to have your own generated integer numbers. If you want to use a voucher that can store your unique IDs if you are generating it yourself. If you want to use a UUID, which I recommend a lot of the time, so many people use UUID, it's a type as well, and you can configure Postgres or some other databases to use it. So, yeah, that can also work. Okay, so if you are using UUID, for example, it means your references should also be UUID because it shows that that is the type of record you are going to be able to put in there, since that is what your table for that particular record type already contain. Okay. So yeah, we have the product ID, which can be is also an FK, right? UUID. This is going to be a foreign key. We have the quantity. The quantity, of course, is fine. If it's an int, we have the price. So for the price, we can put an int, or we can use the currency type as well. We have the status. Status can be a voucher, right? We have the order date, which is a date time. Okay. And one thing we have not added here for now, if you take a look at this, is some constraints on the other types, on the other fields, right? Or columns. So when I say constraint, I'm referring to how this data would, how these fields would treat the values coming in. So for example, for the email, we can say this is meant to be unique. If we say this is meant to be unique, what we are trying to say here is that if someone is trying to create a record with an email that is already existing, this would reject it, right? The database will not accept it. It will say this record already exists in our system, so we can't accept this. Okay, so you can add unique, you can add not null, which is a constraint. For example, if I put not null on the password end there, what we are saying is that the password field should not be null. So if you are creating a new record, this field must be filled, right? Something must go in there. For the created at section here, it's going to be date time. So what you can do is to say this is a, created at, and then you can put an int, or you can use a voucher. So for the created at section here, it's going to be date time. So what you can do is to say this is a, created at, and then you can put an int, or you can use a voucher. generated automatically. So you can do this programmatically in your code, or you can also allow the database handle this to say when a new record is created. I don't need to pass this in, so just go ahead and generate it yourself. And for the updated art, you can also programmatically set this to say if a particular record is updated, let us change the date to the day it was updated. Yeah, so we have the orders table, and we have the order ID, the user ID, the product ID. Quantity, we can choose to say these items should be not null. Something must be there for the, let's see. Yeah, I mean, you can choose to say we should always have an item, but of course, this is for the orders. So if somebody should place an order, you can place an order on, 0 items, right? Of course, you should have a quantity. Okay. And for the price, yes, price, all items, would eventually have a price. Now, this price, you are getting it from a different table eventually, but I'm going to put not null here because, you need to get this price, from the product table and fill that in here. By the way, I think we're yet to update the product table. For the status, let's also say not null because it's either you place an order. When you place an order, it's either it's pending, right, or it has been delivered. Okay. So your order can be pending, it can be delivered, it can be cancelled. So it should be not null. Something must be there. Yes, for the created art and updated art, I think created art can be not null because the value is always there once it's created. We don't need to indicate all that for now. Order dates, definitely compulsory. When you order a particular product, there should be a date for that. All right. So for the table that we have here, what we can do is to also change some of the information here. So looking at what we have right here, we have the product ID. So let's put that here, the product ID. The product ID, primary key, UUID. All right. Yeah, and we have the product name. We have what do we have there? Product description, the price, the created art. You create a new product. I didn't see this mistake. That should be updated at. Now, I'm sure you understand at this point that it must not be the exact fields I'm using, guys. So, but it's good to ensure that the fields you are using is something others can relate to it, okay? So this date time fields, date timing, I want to store the date and the time. Some people will say, timestamp, right? Or timestamps. Now we are just doing modeling. So this would basically differ depending on the database you're using, right? So of course we're giving an example with Postgres, but Postgres is a relational DB, MySQL is a relational DB, Microsoft SQL Server, relational DB. So let's just stick to date time. So the price, int, product description, varchar. This is also a varchar. So these informations are, definitely we'll say not null because this is the constraint we want. People should not put in blank information here. Yeah, people should not put in blank information here. So let's do that here too. The price, not null. So created at, we can say this is now. So it means when you create a new product record, you would have this, you have your database, put the created at date, okay? So right here, what we can now do is the relationship. So we can begin to show the relationship here, just like we have it mapped out here. We can see the order ID is related to the order table. There's a relationship between the order table and the user table. So we can show that here, the order table. So we can say the orders. We can say the orders is related to user. Hold on. Yes, so the users. All right. So we can say the order table is related to the user table, and one thing you would want to show is that relationship type. So what we can do instead, let's just change the direction of this. So we can say the user can have many others, right? Just to show the direction of that relationship. So a user can have many others. Okay, I think that was a mistake. Looking at the diagram, yeah. So the user can have many others. By the way, if you make a mistake here, you see your diagram basically is messed up. Okay, and yeah, so a user can have many others, and there can also be many others for products, right? So a particular product you can actually have many others for one product, right? So what we can also do is to say product like this, others. Okay. So basically what I'm doing here is relationship. I think I made a mistake. It's product. So yeah, that has to be fixed. And we can begin to show the relationship, numbers by saying, this guy has, so let's just say, do something like this. So let's see what that would look like. So if you look at that, what we are saying, I think it should be the other way around. Sorry. Users is, yeah, so it should be the other way around. So what I'm basically saying at this point is, you can have a user can actually have, many others, right? So that's a star. So you have one to many. What most people do is to track that with n, right? So one to many, and you can also showcase the relationships between the others. By the way, maybe I can just jump into Draw IO right now to show you the same thing. So this is a tool for basically drawing diagrams. You can simply get that tool from diagrams. Let's see, Draw IO. Okay, let's just visit the website. So we have other alternatives, right? We have Draw IO. We have I think it's diagrams.net. Yeah, app.diagrams.net. So you can download the desktop version. I'm currently using the desktop version. You can download that as well. You'll be able to, or you can even use it on the web, right? So with this, you'll be able to draw some of those diagrams. We have a lot of diagrams that you can actually draw. So when I press Control N, which is to say, create a new diagram, I can see a lot of, templates in here. I think this is still loading, but I can see a lot of templates in here. Let me try this again. Let's close it. Let's see. Yeah, hold on a second. Let's come back here. It's a page. Okay, that's for page. I think is it a view type I selected? Oh, I see. I see. Okay, give me a second. Give me a second because I'm trying to take off this layout, but for some weird reasons, trying to see how I brought that back here. Okay, let's turn that off. Okay, so I can click on File, click on New, and I'll be asked to select from a template. So I can say, create a new diagram, and you see I'm asked to basically select a template. This is a class diagram, a flow chart, entity relationship diagram, which is what I want. But we have a lot of diagrams here, so a lot of diagrams. So I can click on entity relationship diagram and create a sample. You see we have a sample here. We have customers and we have others, right? Customers can have many others. So if you take a look at this, you see, for the others, we have the order ID, the customer ID, which is a foreign key, right? And it's also not null with the int type, right? So you see the customers are related to the others. So between the others and the shipments, you see others are related to the shipments, right? So of course, you see, you can have one order record. You can have one order type. So for example, a order can be, sent, of course, through the shipment. But the way it works here, take a look at this. You see, we have a foreign key, which is the order ID, right? And we also have, the shipment date. Okay. So I think if I'm trying to model this, what I would basically do is to ensure that, a particular order that I place is tracked with a single shipment instead of multiple. I mean, you see, we have one to many, but the reason why this might be here is because you can actually have a particular order that is moved through multiple shipments. If you think about it, if you have an order with a lot of quantity, and it can be moved through a single shipment, and of course, your order can be moved through multiple shipments, right? So that's why you're seeing this, just in case you're confused. Yeah, this is basically what I'm trying to explain. And of course, you can create even more, shapes, or you can simply copy and paste. So you can actually create more. I can simply search. So let's search. Let's search for ERD. Okay. When I search for ERD, which is entity relationship diagram, you see I have the items that I can basically use, like the table, for example. I can pick up one of these tables and I can click on more results. I don't think I have more items there. Yeah, but I can simply click on this and it creates a new table, right? So I can expand this and I can start putting some of those items, like the items that are primary keys. I can simply edit this as well and just duplicate this if I want to. Okay, but the point is, what we are doing here is we are building our database model, right, and not the actual database. Okay. All right. So I know most of us are not, familiar with, the SQL statements and all that, writing select statements, insert statements. And I actually wanted us to cover that, but I first want you to understand, how to structure and, model the database or the data, before we even get to create, a sample data. So, let me come back to, Draw. So right here, I'm going to, let me just give me a second. Let me check the chat if you have any questions. All right. So how many of us are on the call? How many of us are following? Please drop questions in the chat if you're following. I can see I have about maybe about 10 people. Drop a question in the chat if you're following my explanations. Drop your question or drop a message, right? If you don't have a question, drop a message. Just let me know if you're following, okay? I'm waiting for messages. All right. Okay. So I can see your messages now. Promise Olasokome. Okay. Nice. All right. So let's continue. Okay. Let's continue. Nice. Thank you. All right. So I said we're going to look at some of these things. We've been explaining the database modeling. I've mentioned a couple of terms. I've also explained most of those terms. So you try to understand. We have entities, right? In our database, we have entities, and these are the entities right here: users, objects, products, those are our entities. All right, and then we have the relationship between those entities, which can be one to many, one to one, right? We can also have many to many. Yeah, so one to many, one to one, and many to many. So these are basically described. Most times you have one to one, one to many, or many to many, right? Or you see some other people also describe this with, the asterisk sign. So I'm just explaining this, based on practical, concepts. What you will see most times. So we have one to one, of course, one to many, just like this. Yeah, we have many to many. All right, so just keep that in mind, just in case you see that. You should be able to understand what they're trying to say. You should be able to explain, right? When I provide a data model to you guys, you should be able to explain what this data is speaking to, the type of data based on what you see in the areas here, char 50, not null, right, and all this. Okay. So yes, I want you to be able to explain some of these things. That is why I'm paying a lot of attention, to a lot of details. Basically, I'm giving in a lot of time to explain this in details. Okay, so the entity relationship is what we have been showing as well. The relationship between one entity and another, by relating these items with the primary keys, the foreign keys. This is just a database model. Yes, it is just a database model. So if you search for database models, I mean, I would have loved to share not a whole database, not yet. We have not started building a database, but basically what you have in your model is what you use for designing your database, right? What we are doing right now is you learning how to design the database, okay? And understand the relationships between the database. So if you are in a conversation with someone, and they raise this kind of thing, John and Jones want to build this commerce platform. How do we structure the data? The data that you're going to structure is basically what you will use to define the actual DB when you are ready to work on the actual DB. Okay. By understanding this structure now, we can start creating our tables, right? Where you say, create the table user, and you start putting in this, the columns, right? The username is this type, this is this type, right? So if for some of you that might have seen, what a table would look like, I would show you, but we are not there yet. To be honest, I doubt if we can actually cover that. So if you take a look at this, for example, let me try to zoom in if you can see it. Okay, so this is probably not very clear, but if you can see this is an example. You see we have a table user and we have the information about this user table right here. Well, we're going to be creating that DB. We're going to be creating the tables as well, and of course, I believe I would want to have an additional session where we get to do that. I really want to make sure you understand this concept, so that by the time we get there, it will be very easy for you to follow through on that session. And of course, not just follow, but basically understand very well, right? So that when you talk about databases, you can explain them very well. So let's just discuss some other things here. We have what we call database normalizations. And by the way, what we've done so far is our ERD diagram, right? That is what we're able to create with this. And of course, I mentioned that you can also use draw.io. Okay, so you can use draw.io to even get this template, and you can simply start duplicating this. Most people don't find this interesting, and that is one thing you must understand about programming. If you're a programmer, most likely your friends always tell you, drawing diagrams is not what you should be doing. That's for architects, blah blah blah. And I understand why they say that. But one thing you must also understand is the amount of cognitive loads you can basically carry in your brain when working on a project. Having proper documentations and diagrams, would help you in the long term to actually, remember what you are meant to do, so you don't end up doing more or doing less than what you should do. If you can design your software, design your database before you implement, it's most likely the best way to go, based on experience and based on what I have seen other people talk about or complain about, in the past 14 to 15 years so far. Okay, so just keep that in mind. It makes it easier for you to understand what you are doing, and even if you make a change to this in terms of the relationship, you can simply fall back on your database and make that adjustment, rather than making adjustment to your database first without remembering what you've done, so you don't have any reference to basically visualize what your database looks like. There are so many tools you can use for creating databases. I'm going to recommend one that I use all the time. When I've gotten my ERD, diagram this way, I basically go to the internet and I use a tool called DrawSQL. Now, DrawSQL is it's an easier one because you just have to put in, the values, and it generates that table for you. So you basically, input those values here. It's a free tool. I think it has a paid plan, but yes, I have never used the paid plan for a very long time. So I'm going to sign in, but I don't want you to see, my credential, especially my email. So just give me a second. I have to pull that into a different screen so that I can sign in. Give me a second. Let me just sign in real quick. All right. So yes, if I am signed in, why is it taking this long? Okay. So if I'm signed in, you see, I'm currently in my, come on. Okay. All right. So you see, I'm currently here. We have a lot of, open database diagrams that you can work with. These are some of the diagrams that I've also created, and they are public, so you can basically have access to them. Bit.ly, if you have used bit.ly before, that is a simple public diagram or public database schema. This is one I created for, a business. Basically, I made it public for, I think, a food-related project, right? It's a large one. Yeah, but not extremely large. This is very relatable. You see, we have different tables. We have the profile table, and you can also see we have a lot of relationships happening here. This is a profile. This is what a user profile would have on our system. We have the user record for authentication, email and password, and all this stuff. We have the activity table, which is for logs. We have the preference table, product type, products, the brand, agents, category, the survey table. We have different tables, as you can see, right? We have different tables here. So it's not really like a lot, but the relationships and tracking what should do what. This is the best way to actually go about this. You are able to create those tables by easily, clicking on this. I can create a new table. I can add the properties of the table, just like you see when I click on one of these tables. I can basically edit the properties, and when I'm done, I can also go ahead and save this, right, while exporting the table in actual SQL, right? If I click on this, which we're going to learn how to write SQL statements, not in today's class, but through these means, we're going to learn how to do this. When I click on export, you see it downloads a file, and I can literally open that file, which would show me the SQL syntax that I can then run, right? I can run this syntax, and this would create the table, right? This would actually create the table. So, I don't want to dive so deep into this process just yet, because I would actually need to teach you how to create a table, how to write SQL statements. I mean, I already have all those materials prepared. It's just unfortunate that, 1 hour, obviously, I've said this before, will not be enough to cover all these things, because we still need to go through database normalization, right? We'll talk about first normal forms. I mentioned this the other day, right? Down to third normal forms as well. So what we are going to do instead, is to have a different session, right? Where we'll get to discuss even more and learn, SQL. Okay. For now, we've understood some concepts, but concept is not enough. We need to actually create databases, create tables, create columns, insert items, and all that. So yeah, we need to do all this stuff. Okay. We need to do all this stuff. So yeah, I think let me see. When are we going to do this? When are we going to do this? Give me a second. When are we going to have this session? Hold on, I'm trying to look at the... Give me a second. I'm trying to look at... Okay. All right. So I'm trying to look at my schedule. I will align with a marker, and I will create a different call where we can, continue. We'll study those normalization, patterns, and we'll also get to create a sample database and tables. And I'll show you how to, insert records, delete records, fetch records, update records, with the specific, set of syntaxes, selecting items, inserting items, updating items, and deleting items. I believe, hopefully, before Sunday, we might have that session. If we can't have that session before Sunday, then we'll have that session by next week, Monday. But let me align with a marker, and I'll get back to you guys, because we still have a pending API mastery class. I'm organizing an API mastery class for you guys, of course, for free as well, where I teach you how to design APIs and build APIs in a very easy fashion. So let's try to finish up with this, by weekend or by Monday, and we'll look into the API design class. Okay. So guys, if you enjoyed this session, please do well to drop a message in the chat here. I think maybe a form will be shared with you. I'm not 100% sure. But if it's shared with you, we are going to, I would like you to fill that form and tell me how this class went. Also, let me know in the chat. I mean, you can just tag me. Let me know if you enjoyed the class or not. And if there's something you think we can do better, please let me know as well. Do have a wonderful evening, guys. And yeah, I'll see you next time. All right.